Alright, so continuing on with our test review video, we are on to problem number 8 here. So I want to use the 2A table to determine which major between just political science and sociology has the higher probability of an applicant scoring above 700 on the GRE quantitative test. So looking at my data, I'm looking at political science, I'm looking at sociology, and I'm focused on those scoring above 700, so this 700 to 800 range. Now I can see that I've got 4,251 in the political science major who scored above 700. I have 599 in the sociology major who scored above 700, but it's not enough to compare the raw data. It's not to say, well, there were over 4,000 people in this major who scored above 700, and there were under 1,000 in this major who scored above 700, so political science is greater. It makes sense that political science has more people in this area, 700, 800, because they have more people altogether in that major. There are almost 20,000 political science majors, while there are only about 4,000 sociology majors. So you can't use the raw data, you've got to compare the percentages. So for my political science percentage, I took the 4,251 divided by the total of 19,960 total, and that gave me 21.3%. And then for sociology, I took the 599 who scored 700 to 800, and then divided by its total of 4,404, and that gives me 13.6%. And so therefore, political science majors do have the higher probability of scoring 700 or above based off of this two-way table. Number 9, which variable would have the higher standard deviation? Y. Variable A is the daily high temperatures of Tallahassee during the summer, and variable B is the daily high temperatures of Tallahassee throughout the entire year. Remember, standard deviation is a measure of spread, a measure of variability, and so I'm saying the daily high temperatures throughout the year would have the higher standard deviation. If you think about temperatures throughout the year, the temperature can vary widely. So, some days in the winter, the high only hits the 30s. 40s sometimes, and then in the summer we have highs in the 90s or even the lower 100s. So you've got quite a span of temperatures there, quite a lot of variability when you're looking year round. Whereas in the summer, it's pretty consistently hot. Maybe a few days where the high is in the 80s, but we're mainly in the 90s and the 100s. So the data pieces would be much closer together when you just consider the summer. So higher standard deviation would belong to temperatures throughout the year. Number 10, a research group decides to study the relationship between coffee and REM sleep. There are 4 randomized groups. The first group gets no coffee for a month. The second group drinks 2 cups of coffee each day for a month. And the third group drinks 4 cups of coffee each day for a month. And the fourth group, they drink 2 cups of decaf coffee each day for a month. The amount of REM sleep is measured each night. And the study shows that the third group, the group that is drinking 4 cups of coffee each day, has significantly less REM sleep each night. Part A, I want to know, is this an observation or an experiment? This is an experiment. With an observation, you typically just ask questions. You don't have any control over what people in the study are doing. But in an experiment, you split them into groups, exactly as we did here, and you have different groups do different things. You have a control group. That's the first group who gets no coffee for a month. Then you've got your treatment groups getting 2 cups of coffee, 4 cups of coffee. And then you have a placebo group who is getting the decaf coffee. And that answers part C here. The purpose of the fourth group, they act as a placebo group. The coffee looks like the real thing, smells like the real thing, but shouldn't have the effect of coffee without the caffeine there. So we're introducing a placebo. And then part B here, what conclusion can be made from the study? Because this is an experiment, I can say that 4 cups of coffee each day from that third group causes, there's a cause and effect relationship here, it causes a reduction in REM sleep. Had this been an observation, I can say there's some sort of link, there's some sort of relationship, but I can't use the word cause with an observation, only with an experiment. There we go. Next up, I want to look at some examples of multiple choice questions. Your first test will consist of multiple choice questions and short answer questions. This is a good idea of how some of the multiple choice questions may look, the thought process you'll have to go through. And the key is to use your answers and see which ones make sense and which ones don't make sense. So number one, this box plot describes the standardized test scores for 1,031 students. Which of the following is true? So what we're going to do is use the fact that each component, no matter how wide or how narrow, contains about 25% of the data. So this whisker contains about 25% of the students, as does this box, and this whisker. So A says at least 60% of the students scored less than 70 on the test. So here is 70. That's the mark in all of these. We're looking at less than 70 in part A. So less than 70 is on this left-hand side, and so I've got 25% here for sure, 25% here for sure, so I'm at 50%. It could be 60, but I don't know how this 25% is split. Is it 5% here and 20% here? Well, that would only put me up to 55%, not 60. Or is it 15% here and 10% here? I don't know how the individual data pieces are spread out, so I'm not too sure about A. B says at least 60% scored greater than 70. Well, there's no way that's true because I have 25% for sure up here, and I have some part of this 25%, but not enough to boost me up to 60. The correct answer here is choice C. At least 30% scored less than 70. Well, less than 70, I know I have at least 50% with these two together, so 30% is definitely there. At least means number there. And then finally on D, at least 30% scored greater than 70. Again, I can't be certain about this one, just like in A. I know I've got 25% above the 70 with this whisker, but I'm not sure about the breakdown of this box here. Again, is it 20% are clustered here and only 5% are here, or is it 10% here and 15% here? There's no way to know without seeing the data there. Number two, a 13-year study of 1,328 adults randomly selected from a population are carefully monitored. We look at their personal habits, their health conditions. Personal habits are tobacco use and coffee consumption, health conditions, incidence of stroke. Which of the following cannot be answered from the study? And this comes down to the fact that this is an observation and not an experiment. We're not dividing these adults into groups and having them do different things, having a control group and a treatment group. We're just monitoring what's happening over these 13 years, so we can say there's some sort of link, there's some sort of relationship between these things, but we can't say that there's a cause and effect relationship between these. And so that's why I went with B. Here's the choice. I can't say that coffee consumption causes a reduction in the incidence of stroke. Just because this is an observation, there may be some confounding variable in there, something I didn't study that's having an effect on both of these. So I could conclude that coffee drinkers are more likely to smoke than adults who don't drink coffee. That might be possible. I'm not saying there's a cause and effect relationship there, that's just there's some relationship. C, do coffee drinkers have fewer strokes than adults who don't drink coffee? Well, we could look at the data and see, did that occur? But I'm not saying there's a cause and effect there. And the same thing with D. I can find the percentage of population that are coffee drinkers. I'm not looking for any cause and effect, and that's okay because this was observational. Moving down to a third multiple choice example, another observation versus experiment. In a sleep study, researchers asked a random sample of college students how many hours of sleep they typically get each night. They also recorded each student's GPA. The results showed that students who sleep less than 5 hours a night are twice as likely to have a GPA below 2.5 than students who sleep 7 or 8 hours a night. So can we conclude sleeping less than 5 hours a night causes a college student's GPA to drop below 2.5? And the answer is no, because again, this is an observation. Researchers just asked a random sample of college students how many hours of sleep they get each night, and they recorded their GPA. They're just observing what's happening. We're not placing people into groups and having a control group and a treatment group. It's not an experiment, so we cannot use the word cause here, all because this is observational. Moving on to the last page of the review, thinking about populations and samples, how to get a good sample. Number 4 says a study was designed to estimate the proportion of adults who intend to vote in the next election. They want to generalize results to all voters in the next presidential election, and they poll a sample of 100 adults who attended a Major League Baseball game in Tampa and volunteered to take the survey. Will this likely represent the entire population? Well, if you want to talk about everybody in all the states, we're talking Maine, California, Texas, Florida, Nebraska, we need people from all of those states, and we're only looking at 100 adults at a baseball game in Tampa. So we're only looking at a very limited section of the population, so this is a no. It's not going to represent everybody. It's not because baseball fans may not make a majority of U.S. voters. We're not even looking at baseball fans. We're looking at people at a baseball game in Tampa, so not fans of other teams necessarily. This is a no because it's a voluntary response sample. It's not a random sample, and it's just of people at a baseball game in Tampa instead of a random sample of people across the country. D is our choice. On 5, which of the following data sets is the median a better measure of center than the mean? You use the median and the IQR when your data set is skewed, and you use the mean when you have a symmetric data set. The mean and standard deviation for symmetric data, median and IQR for skewed data. If I look at A, you've got 10 in the middle. 2, 4, 6, and 8 are just as clustered as 12, 14, 16, and 18. This is symmetric, so I would use the mean for choice A. But on B, you've got 16 in the middle. 1, 2, 4, and 8 are much more clustered than 32, 64, 128, and 256. You've got this skewness to the right, so because this is skewed, you would use the median to describe the center here. You would also use the IQR to describe the spread. C is a symmetric data set. You've got 1 in the middle. These ones are just as clustered as these ones. There's no spread there. And then in D, you've got 0 in the middle. These negative numbers are just as close together as these positive numbers. So these in A, C, and D are symmetric. We would use the mean, but B is skewed, so we would use the median. And then wrapping this up, if the value of the mean is smaller than the value of the median, the distribution is typically skewed to the left. And that's something we discussed in Chapter 3. If your distribution is skewed to the left, the mean is usually smaller than the median. If it's skewed to the right, your mean should be larger than the median. And if it's symmetric, then your mean and median should be fairly close to one another. When you're going through and getting ready for this test, also be familiar with the ideas of confounding variables. That was discussed back in Chapter 1. Remember, that's when an observation when you have a variable that you didn't study that could be affecting the two variables that you did study. And then the idea of standard deviation. When you have a standard deviation calculated, what does it mean in context? Remember, standard deviation is how much your values typically vary from the mean. Typically vary either above or below that mean. Right, so use the study guide to help you prepare for your test. Use the old videos and use your notes, and you should be all set.